take the Mayan Indians. They had a writing system, and we know some of the things they wrote were astronomical things, and they had a scheme for predicting many things in the sky, eclipses and so on. And let's take the example of when Venus, which was important to them because it represented evil of some sort, was a morning star and when it was an evening star. So they could predict ahead of time whether this bad influence was going to be in the morning or in the evening. And so they discovered that if they waited, that this cycle of morning, evening, morning, evening, morning, evening, 5 of those occupied just exactly the same time as 8 times a certain period that was important to them, 365 days. It's not exactly a year, and they knew the difference, but they still counted in 365-day intervals, which they called a tune. So they said that 5 of these cycles is 8 tunes. Then they discovered, of course, very quickly that if they did this 5-cycle bit for 8 tunes 10 times, they were off by about 6 days. And so they had a rule for shifting, making corrections as they went along, and thus had a very good way to predict when Venus was coming up. Okay? Now let's look at this thing from a point of view. Suppose that the professors, the priests in those days, who wrote this stuff and taught their students these rules, were giving a lecture to try to explain what they did in order to make these wonderful predictions about Venus. Then, if the fellow was any good at exposition and really knew what he was doing, he would say, what we're doing is we're counting the days, just like you're putting nuts in a pot. And we keep on counting 365 nuts, and then another 365, and another 365, and another 365. The guy says, what a lot of work. And when we get all finished, we say, that's 5 of these periods. Now they understood what he said. That's easy. They did not know a quick and tricky way to add 365 times 8. I'm sorry, I said 5 times. I meant 8 times. The students were learning in the meantime the laws of arithmetic, something which is to us now, because we have public and free general education, almost everybody has to struggle through and learn how to add numbers by a tricky scheme of writing them in place system and making carryings and so on, so that if you buy wine for $4.15 and your meal is $2.87 or vice versa, it costs $7.02. And the girl who does this, the waitress, just an ordinary person, in 2 minutes does that. How did she do it? What is she doing when she's adding $4.15 to $2.87? She's doing this, counting out 415 pennies, then counting out 287 more pennies, and telling you how many pennies you would have got if you counted them all from the beginning to the end. But it's highly educated and very trained to be able to do that with those large numbers quickly. This training is something, in spite of the fact that everybody's got it. It's something pretty good, because in the 14th century, mathematicians they were called who could do that. Almost everybody in our civilization can do that, but I took this example, you can understand what's involved. What the students are taught, you see, in our particular problems now about physics, there are many bigger numbers. The numbers are much bigger. It's hard, the numbers are so enormous you can't count them directly. And so we've invented a fantastic array of tricks and gimmicks for putting together the numbers, adding, counting, checking, and so forth, without actually doing it the way I could describe what we're trying to do. If I say, I draw this, and I draw that, and I draw this, and I draw that, and I see where the end point is, we don't actually sit down and draw 7,000 arrows and find out where the end point. We have a way of figuring out where it'll come, just like we don't actually count 415 pennies and 287 pennies to find out that you owe me 702 pennies. We do it by another trick. These are the tricks of mathematics, and that's all. So that's the part I'm not going to worry about. We're not going to worry about that. So don't relax. You don't have to know mathematics. All you have to know is what it is. All it is tricky ways of doing something which would be laborious otherwise. So it's true that in the years we have developed enormous abilities in mathematics, and it takes a long time to train the students, and so therefore they're very highly educated in that. But if you ask them why, now we go back to the Mayans, we ask them why the rule. Why, when you fill up a tub 8 times with 365 day markers, it comes out that the Venus is up 5 times? They don't know. They don't understand at all. The more accurately they can do it, the fact that they know that they have to change it by 6 days and so forth, adds nothing to their understanding of it. The student who has learned all this mathematics and is able to make these calculations, not only of Venus, of the Mars, the Sun, the eclipses, and everything else, is a super priest. Doesn't know why any better. And if he would explain it's nothing but counting days, he would be reduced to the truth on the one hand, and to an honest statement that he doesn't understand it. On the other hand, and could tell somebody all about it who doesn't know how to count all these numbers so trickily and so cleverly, as this priest students knew. Okay. Now, probably, I don't know about philosophy of Mayas. We have very little information due to the efficiency of the Spanish conquistadores and, well, mostly their priests, who burned all the books. They had hundreds of thousands of books, and there's 3 left, and one of them has this Venus calculations in it. So that's how we know about that. And just imagine our civilization reduced to 3 books. The particular ones left by accident, which ones, see? So, anyway, I get off the subject. I make this up now. What I'm saying now is just a story. Suppose now that the students would discuss, or people would discuss the possible meanings of this. Why? Then they would begin to think about, well, 8 times 365 is 2920. That's got 2 2s in it. Now, 2 is a lucky number, and it has 2 2s in it. And then the 9 represents the god of so-and-so, which is related to Venus, and so forth, and that would be a good argument. Then, but in another city, some other guys getting together who have a different kind of an argument about it. They say, look, now, the fact that there's a 20 at the end, if I subtracted that away first, I get 2,900, which is a especially good number from blah, 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 and so on. And they would have different theories. And then someone would come along and say, you know, it doesn't make any difference which one of these theories is right. We still have this fact to go along with. And that is our modern scientific point of view. In the earliest days of science, we got confused arguing philosophically what was a reasonable reason for nature abhorred a vacuum, or it seemed to be nice that gods were doing it. Different kinds of psychological reasons for thinking it probably is all right after you discovered what it was. These things were never useful for predicting what should happen next, and we soon learned not to make these arguments. It's useless. It doesn't add anything, and so we're not going to make my imaginary Mayan arguments about the various gods that make the numbers. And so I'm left, if I'm a modern scientist, with a description of the situation. All right? Now,